All right, hey guys, Marina here with another stats video. I'm going to start here. This is Monday's lesson. If you're watching this video tonight, this is tomorrow's lesson. This lesson is going to be on how to make a confidence interval, and instead of the difference between two proportions, it's going to be the difference between two means. I'd like to start here with the two-question do now. I'm not going to read the first question. You could pause it and read it to yourself. It says we want to make a 95% confidence interval. So 95%, we go to table B as we've been doing. You get the Z star for that, which is 1.96. So I'm going to go ahead and cross out choice C, choice E. I'm also going to go ahead and cross out choice A. That doesn't even have the 1.96. It also says that there is two companies. I'm going to jot down some information that they give us about both companies. Company A and Company B. Company A, the sample size is 125. And Company B, the sample size is 68. It also says that 35 out of the 125 people from Company A are admitting to using sick leave when they're not really ill, which actually comes out to be a sample proportion of 0.28. And in Company B, 17 out of those 68 people admitted the same thing, which I was going to calculate, but I can actually figure out what the answer is between those two choices. The one that has the correct numbers is choice B. All right, now you can go ahead and pause the video and read question number 2. So one thing I notice here about this confidence interval is that it does include the number 0. And judging by Friday's conversation in the Google Hangout, as well as messages that you guys sent me on Remind, some of you guys are still confused, rightfully so, about what the hell does 0 mean in a confidence interval. Well, if the confidence interval is about the difference between two proportions, or what we're going to do today, the difference between two means, 0 means that there is no difference. No difference means that the two proportions can be the same. So since 0 is in this interval, that means that we have evidence that the two proportions can be the same. Another way of saying that is that we don't have evidence that they're different. And the one that correctly says that is choice C. And rather than make this video longer than it needs to be, if that's still something that you're confused about and you want me to explain, hit me up on Remind, talk to me in the Google Hangout, whatever you got to do to make sure you understand that. Judging by text messages, phone calls that I've had with other AP teachers, and things I've seen on Twitter and YouTube and the news, sounds like Chapter 10, which we started on Friday, is going to be the last topic that you guys are going to need to know for the AP exam. I'm pretty sure some of you guys are sitting there rolling around the idea that, hey, you know what? If it's going to be a 45-minute test, or if this year is just so totally screwed up with everything that's going on, I'm going to go ahead and cancel my AP test because somebody told me that there's no penalty. You could not make a worse decision this year if you go ahead and do that. I know I'm biased and I have my goals for you guys, and you're probably sitting there laughing going, yeah, okay, Marina, you just want 70% of us to get credit. But honestly, this year, with the way things are going, I have a feeling that this test is going to be one of the easiest tests there is. And in a 45-minute window, I really can't see them asking anything too complicated. So this is going to be your best shot of getting college credit. So once we find out more information on April 3rd about what the heck's actually going to be on this test, we will do everything we possibly can, however that may look like, whether it's in school or online, to practice whatever questions AP Central says, topic-wise, what's going to be on a test. But it should only be up to Chapter 10, so we're not going to even touch Chapter 11, which is chi-squared, or Chapter 12, which is inference on things that have to do with slope. So this is the last stuff. I'm going to try and get it done by Friday so we can spend the remainder of the school year reviewing free response questions, since there are going to be no multiple choice questions on the AP exam now, from what I've heard. I'm just going to toss those out the window, even though I've spent so much damn time going over those with you guys this year. That's a story for another day. All right, so this lesson is about making a confidence interval for the difference between two means. You can go ahead and pause the video if you feel like and read the question to yourself. All right, so step one in making a confidence interval is, again, we want to estimate All right, so now we're not talking about anything about proportions. We're actually estimating to see if there's a difference in the mean salaries between these two professions. So we want to estimate the true mean difference. And I'm going to go ahead and write down that we're going to be doing the difference mu1 minus mu2. You can label those differently. You could say mu p for politicians and mu e for EMTs. I'm going to use 1 and 2 just because I want to get you exposed to other ways of doing this. And we want to make sure we have context. So and you're probably wondering if you need to subtract them in any specific order, or should you make sure you're doing them, biggest number minus smallest number. There's no rule. It really doesn't matter. This is how I'm doing this question. And I'm going to go ahead and write down that mu1 is the true mean salary for all politicians. And therefore mu2 is the true mean salary for all EMTs. All right, so step one, you stated what you're going to do. You're going to make a confidence interval. You're going to estimate the true mean difference in salaries between politicians and EMTs. Now, for step two, we're going to check our conditions. On Friday, which was a 2-prob Z interval, well, now we're talking about the difference between two means. So this is called a 2-sample. And again, don't forget with means, it could be a Z interval or it could be a T interval. So let's go up and see what we were given here. I see we were given some standard deviation. It does not specify that is the population standard deviation, which again would be that symbol. That means this standard deviation is coming from the sample that they took of the 50 politicians and the 100 EMTs. So this is going to be a 2-sample T interval. And if you're looking ahead to where the heck that is in your calculator, you would go to Stat and go to the right for tests. And you will go down to number 10, which actually is just going to look like a number 0. And you'll find it there. So conditions, we have to have random samples. And we do. So go ahead and check that off. 10% condition still applies here. So we're going to have to assume that there is at least 10 times 50 politicians. Sure. And we're also going to have to assume that there's greater than or equal to 10 times 100 EMTs. Sure. Now for normal, we don't have to worry about any of that n times p nonsense or n times 1 minus p nonsense because this is a means question. So central limit theorem, greater than or equal to 30. But we do have to check both sample sizes. So the sample size for politicians was 50, and 50 is greater than or equal to 30. And the sample size for EMTs was 100, and that's greater than or equal to 30 also. So boom, you're done. You're all set. Conditions for means is much less work than conditions for proportions. This is also known as the central limit theorem. I'm going to go in there, boom, just for some extra flavor. All right, so step 3, formula time. This is going to be, instead of p hat 1 minus p hat 2, you've probably guessed it, it's going to be x bar 1 minus x bar 2 plus or minus, not a z star, this is going to be a t star, so we're going to have to go to table B. And then the rest of it, the standard error part, bear with me here. Again, I can already hear the complaints. This is going to be standard deviation squared over sample size 1, and then standard deviation squared over sample size 2. And if I want to put a little 1 and a 2 there, that's fine. So x bar 1 minus x bar 2. I made subscript 1 the politician, so that's going to be the sample mean 61,234. Plus or minus. Okay, now, T star. Remember, with T star in table B, we have to talk about degrees of freedom, which is n minus 1. But we have two different sample sizes in this question. We have a sample size of politicians, which is 50. We also have a sample size EMTs, which is 100. Here's what you do. Go with your smaller sample size. Which is 50. That means your degrees of freedom, it's going to be 50 minus 1, which is 49. So I got to go look for 49 degrees of freedom and make sure that we look at our confidence level, which is 99%. So let's see, table B, 99% confidence. So over here, 49 degrees of freedom. Let's see, I see 50. I don't see 49. Remember, we round down, so we're going to go with 40. And I'm looking at 2.704. So let's go ahead and fill that in. This is just to show work. And now we're just plugging in stuff from the problem, from that table, which is actually really nice. This would be 7,524 squared over 50, and then okay, now calculator time. Again, you go stat tests, go down to number 10, to sample T interval, put all your data in, and it gives you a confidence interval. Okay, so that confidence interval is the true mean difference in salaries. And remember, I subtracted them in the order of politician salary minus EMT salary. So I see that those numbers are both positive, which means politicians are making about somewhere between $3,534 and $9,875 more than EMTs. And I also noticed that zero is not in there, but we'll talk about that in a second. Let's make our conclusion. All right, so that's how you do a 2-sample T interval. And question B, before you guys try one by yourself, does that interval provide evidence that politicians have higher salaries than first responders? Why or why not? Sure it does. First of all, those numbers are both positive, and I did politicians minus EMTs. So if I'm subtracting those means and I'm getting a positive number, that means the politician's salary is higher. And I also noticed that 0 is not in that confidence interval. 0 would mean that both average or both mean salaries are the same. When you subtract them and get 0, that means both numbers would be the same. And since 0 is not in that interval, that means that we do have evidence that the salaries are different. So, yes. All right. So that's that. You guys can go ahead and practice this one, and I will talk to you guys tomorrow and see if you guys have any questions. All right. Have a great night, guys.